All right. Well, good morning, everybody. Thanks for coming. Wow, Sunday morning on DEFCON. We're here. Yeah, that's all about I have to say about that, I guess. So, if I haven't met you yet, please stop by, say hi sometime, or grab me in the hallway. James Shewmaker. I do some incident handling and penetration testing stuff. The past year, I've been doing a lot of research on some of the tactical-based stuff. Has been my emphasis. And this is kind of a result of some of that experimentation. Some of what we're covering today is, defense is hard in general, so some of the stuff we're covering today is a start on closing that gap, making up for some of the deficiencies we have in our browser-based environments. So that's what we're going to talk about today. So, just to kind of wake us up, maybe get us all started on the same foot here. Browsers aren't good enough in the way they are right now. Generally speaking, or why they have extensions to fill in those gaps, right? We've got Flash players, we've got all these other rich content extensions in our browsers, and that between the two, they're incomplete and quirky because of the incompleteness, makes them even more quirkier, right? We have all these plug-in variety versions, things get complicated, and it really gets even quirkier because, all the web content we have is so customized, right? We have the HTML itself is all written maybe by hand, maybe by a broken editor, and then we have all the media on top of that gets delivered. So today we're going to be focused on two types of those problems that manifest because of that. Some of the attacks, or at least some of the attack components, we'll look at some techniques to do that. And then also, how can we regain some of that anonymity? We'll look at a few examples of some things that maybe are steps in the right direction to re-anonymize ourselves after some of the work that's been done in the past year or so, roughly. And then we'll introduce X06D, which is it's like pre-alpha version of a suite of browser-based defenses that we've been working on. But the goal of the project is to get us close to, maybe we'll be okay. There's that 6-day window where we might have some issues, but within 6 days of knowing that there's an issue, we'll be reasonably safe. That's kind of the goal. We had to pick a goal, so that sounded like a good one, roughly a week. So overall, this stuff we'll be covering, it takes, let's say, 4 phases, right? To defend yourself against attacks, we want to sanitize the input to the browser. Say you actually were duped into clicking on something or browsing somewhere you shouldn't. That input to the browser being half of the application, typically, is going to be a large portion of that attack surface, right? And you don't have much control of that from the server's aspect, right? You have no idea if it's a public site, who's coming, what they're going to come with, how nicely configured their browser is, what it's vulnerable to, and all those sorts of things. So to defend yourself in a browser on a public site, you might want to first identify what interesting code is showing up in the browser because, there's so many different combinations and encodings and complicated things that need to be renormalized down to something you can detect. This is why we can't take the classic antivirus signature technique and lean on it as heavily as we have on the host level inside of the web applications because there's so much custom things that we can't detect. Now, some of the things we can do, we've seen some progress, right? NoScript is a very cool tool. Lets us do a lot of awesome granular control of what comes into that browser. Rejecting tags, rejecting certain scripts from certain sites, even whitelisting sites. But it is somewhat limited, right? Because it is still not available for every browser, of course, and it's more, because it's so granular, it is more tailored to those of us who care to go in and manually do all these settings, right? We can't just set it and forget it. Not that I ever think that's a great idea for security concerns, but it's still something that would be nice for all those sheep that want to come to our sites, right? Or the ones we have to protect, to be able to give them something that will protect them without a whole lot of foot shooting, you know. Another portion is if we can anonymize the browser. Now, I want to separate out a couple things. That's why we have anonymized and randomized separately here. Sometimes people can confuse the two in our application here. But if we make the browser look more or less unidentifiable, at least indistinguishable from other browsers, then it's going to be less likely the point of the attack, right? There's not going to be a specific weakness in that specific version of the browser, or the enhancement to the browser like the Flash player is going to be less likely to be targeted. So being anonymous there would be great. Now, we could look like clones of each other, and that would be sufficient, but maybe it'd be more interesting to fake being somebody else, right? Using a browser fingerprint that somebody else had. You know, back in the earlier days of the internet, where we had, well, I don't know about the whole internet, but when we had the web, right, and Netscape went public, and we had a few browsers out there, if you can call them that, there was, you know, an interesting thing as sites try to detect, you know, hey, do we need to put this in a way Internet Explorer can display it for you? Try to detect your user agent, usually, to display it in a Internet Explorer friendly way versus, you know, the Netscape way. Well, that was an earlier way to try and identify things. Of course, there's easy ways to spoof that. The user agent string being controlled by the client, real easy to just fake that, and that's what they did to make our browser look like every other browser. There was the user agent forgers. One of the first reasons many people used Opera was because of that feature. You know, they can make it look like Internet Explorer, so they got the Internet Explorer version of the site. Another great thing now is to make your web browser look like a mobile device, because now you don't get the Flash version of the site. You get the leaner version of the site, right? Because the iPhone won't support Flash. So there's a lot of reasons to make yourself look like everybody else. But it's much harder than just changing the user agent string. But hopefully you see the benefit in that, as well as just, it would be sure nice to not just look like everybody else, but to look like that iPhone, to get that iPhone version of the site. And then when we come to randomizing stuff and applying this as a technique to defend ourselves, this is more of a strict privacy kind of concerns, right? Where we don't want to either reveal our behavior, or we don't want to be singled out for anything in particular. There's a couple of ways that we can do that in general. We can groom our history so that it looks like everybody else. It's kind of similar to the anonymizing, but here it's more for the behavior. So we, in the background, go to those top 500 sites from Alexia in the background, so that if someone's watching on the wire, they see normal traffic to Facebook and all these top 500 sites. A little harder to fingerprint that, oh, this IP address is very specific and unique, because, wow, you've got to wade through all this other traffic that is typical. Raising that noise level, creating that line noise. And then, of course, the other thing to come full circle is to sanitize output to the server, right? So sanitizing input to the browser that we have at the top of this slide, what I mean by that is if you're duped into injecting into yourself, right, you're going to catch it there. Like a classic cross-site scripting attack, or maybe you clicked on a phishing link and you're sending something in your own browser. Sanitizing output to the server, you know, maybe your browser's vulnerable as it displays things, as it renders the HTML is where the problem happens. So it's nice to be able to deal with both the input and output in that way. Now the ways we can defend against that is, of course, we might be able to do a signature detection, but again, that's complicated and hard because we have to renormalize the code, right? If it's a script tag that's modified, we have to detect it in an unmodified version, so we have to renormalize it. And the trick is really different browsers normalize it differently, you know, take different priorities in recombining code. So the other way really than detecting it is to try and neuter what looks interesting by just translating it, just kind of munging it a little bit so that it is less likely to work precisely how the attack was constructed, somehow converting it. All right, so to try and deal into it a little bit deeper, if we're sanitizing the input to the browser, we've got no script, but it's hard, right? You still have to go in there and do that granular check. You've either got to whitelist what you know you're going to trust, and then you might get caught with something dangerous there. What are some other options? Well, maybe we could actually vote on what is allowable or not, right? Have more of a peer-based evaluation of what is good content. In concept, that sounds pretty scary. I don't know about you, but when I look out and see my peers, I don't know if I would trust them to dictate what I put in my browser. But maybe that works for all those sheep out there. Maybe. I don't know if I want the next Farmville plugin to be whitelisted, but you know, it's an interesting idea that maybe in certain organizations it's okay. Especially if you make the voting system a little more, well, you engineer the voting system to take advantage of it. For example, the vote is prompted to be, should you or should your coworkers be wasting your bandwidth watching these videos on this site? Yes, no. If you engineer it in that way, maybe people will then vote a little more harsher. But it's an interesting idea. There's been some examples of people trying to do that for spam, and there's the Dan's Guardian Squid voting mechanism that people have experimented with a little bit for the web filtering. So it can't be any worse than what we've already got, I guess, is what I come down to. But maybe we introduce more complexity. So I'm not going to lean real heavy on that, but it's an interesting idea. We can at least do a public blacklist, but it's a hard problem. All right, so again, we've got the applications kind of split, right? Half of the problem could be on the client side, half of it could be on the server side. We've got all these different layers though, right? We don't just have to attack the application. We can attack HTTP, we can attack TCP, we can attack IP, we can attack DNS that gets us to IP, and we've still got ARP, and we go down the stack for DNS as well. I mean, we can attack any one of those layers. It's going to be a problem. And then there's all the contextual problems that are kind of manifested. If you haven't seen Arsenic and Jabber's De-Anonymizing You last year at DEFCON, you really should go and review that, especially if you haven't seen it for a while. It's good stuff. One of the goals I had for this talk was to see if we could at least start addressing the issues they talked about. And we're close to getting at least proof of concept type to address each issue now. And then if you saw, was it Friday, Peter's talk on the Panopticlick from EFF. How many people saw it? Yeah? Awesome. Yeah, so that was good. You can go to panopticlick.eff.org and look at the paper, or you can go back and buy the video or find it somewhere and see him explain some of the details of the anonymization. We'll be looking at a couple of things that are very similar, but for those of you who haven't seen it, the idea is that there's all these different bits of information that can identify your behavior or your browser. There are some things in headers. There are the header sequence. There is your history in the browser, the system fonts, the unique combination of plugins you have. There are many ways to go through and detect you, and that's the idea of the Panopticlick experiment. It's a good start in trying to work out some of these issues. So a couple of things about the fonts, for example. Fonts and plugins are the hardest part to de-anonymize, or excuse me, to re-anonymize. They're the easiest thing to de-anonymize. But we can go through and there are flash calls to pull in the system fonts as a feature, very simple. There's some other examples too where via changing or comparing two different div tags that use different fonts, the width and the height of the font will tell you if that person has which particular font installed, or if the browser had to go grab something else in that family to display it. So it's not as precise detection, but it's still enough to maybe track you as you, right? The plugin stuff, add-ons, extensions, depending upon what you read, are even harder though, because well, that's more of an internal browser thing. It's not something we